So, the next talk will be given by Ms. Evelyne FOERSTER about probabilistic safety assessment for internal and external events. Ms. FOERSTER obtained her engineering degree in 1990 at the École Centrale de Lyon in France and her PhD in numerical methods for geotechnical engineering in École Centrale Paris. She has more than 25 years of experience in the development of numerical methods and tools dedicated to geohazard and risk assessment, and extensive experience in national and European research project coordination. Currently, she is the head of the Seismic Mechanics Study Lab at the CAA in Paris-Saclay, and director of the French Seismic Institute and coordinator of the Horizon 2020 NARSIS project. So the floor is yours.
Thank you, Mr. Chairman. So I will change the subject from this morning, I suppose, because I will talk about probabilistic safety assessment, and I will present only 2 projects, which is quite easy compared to the other colleagues. I want to acknowledge my co-authors, Emmanuel Raymond and Yves Guiguenot from IRSN, who were coordinators of FP7-ASAMPSA-E. So about the context for this topic. Okay, yes, less loud. About the context of these 2 projects, of course, the Fukushima accident, which highlighted a number of challenging issues regarding external hazards and aggressions to nuclear installations, for instance, cascading or conjunct events, and for instance, cliff edge effects or scenarios. This led to the questions regarding probabilistic safety assessment relevance, mostly in practice, for such extreme events. So low probability with high consequences, external aggression. And there were, after this, several initiatives at the international level regarding the review of current practice and the assessment for nuclear power plants, especially for robustness against extreme events, and also to identify some possible gaps or reinforcements that were needed. And from conclusion of OECD, the risk analysis regarding this assessment, safety assessment, should include, as possible, the interactions and dependencies that were observed during, for instance, Fukushima. So include also cascading effects and combinations of events and possible impacts, which can be external or internal to the plant, and try to cover the whole site and not only single parts of it. So that was the main conclusions. And also some bottlenecks were identified in probabilistic safety assessments regarding the process, which was not straightforward for all the external hazards. For instance, the single assessment was not straightforward for all, and in a multi-hazard context it was even worse. So for cascading or conjunct events. Regarding extreme events in a probabilistic assessment context, the issue was that for instance, extensive Monte Carlo simulations provide only a partial solution to the assessment. Regarding integrity assessment or fragility, most of the analysis were focused on physical damage for components, and the assessment of functionality loss for equipment was not fully integrated in the fragility models available. And finally, multi-hazard characterization and harmonization were addressed by a few European projects, and the purpose was to see whether they were applicable to complex systems such as plants, nuclear plants, and if we could demonstrate their application. So this led to the launch of two different projects. The first one was ASAMPSA-E and the former ASAMPSA projects. The one I'm talking about today is the ASAMPSA-E for extended probabilistic safety assessments regarding safety assessment methodologies. And it has been launched in 2013 and was aimed at identifying good practices for probabilistic safety assessment and to accelerate the development of extended PSA. I will come back to the definition of it. And the ongoing NARSIS project, which I'm coordinating, has been initiated in 2017. And the purpose here was to identify gaps between practice and needs, research needs, for instance, in existing methodologies regarding multi-hazards, external multi-hazards and scenarios, and to try to improve parts of the methodologies, not the whole, but try to see how we can improve some part of it. Regarding ASAMPSA, there were 31 partners, 28 in Europe and 3 outside, so 2 in Japan and 1 in the States, United States. Extended PSA, what it means. So it applies to a site of 1 or several nuclear power plants and all the environment of these plants. So it intends to derive the risk induced by the main sources of radioactivity on the site, and to account for all operating states for each main source and all possible relevant accident initiating events that can be both internal and external, that can affect the whole site. So an extended PSA should include at minimum what we call level 1 and level 2 assessments. So level 1 is for scenarios of fuel damage and their frequencies, and level 2 is for scenarios of radioactive release, frequencies, kinetics, and so forth. And it may include also level 3, which is more related to the calculation of risk to the population, the environment, and the induced consequences to the economy. And regarding existing plants, there should be a link with the design extension conditions concept also. So the ASAMPSA project helped at the European stakeholders and non-European, because they are outsiders, to accelerate the development of extended PSA and to verify that all the major contributions to the risk induced by the interaction between the site, the plant, and its environment are well identified and can be managed. This is the whole purpose. Thanks to this project, there was a share of a good practice. There were many state-of-the-art productions and so forth, and a good network of more than 100 experts from the consortium that could cover all the sector, I would say, going from research to the industry. About the main achievements, as I said, this project was useful because it produced lots of materials, more than 27 technical reports that were published by the consortium, and dealing with many topics. So general issues about probabilistic safety assessment, of course, so lesson learned from the Fukushima accident, list of external hazards that can be relevant to be considered in this assessment. For the end user community, there were mainly 4 or 5 main hazards that should be considered related to earthquake, flooding, extreme weather, lightning, and etc. And there were also some general considerations about the methodology for selecting, initiating events and hazards, about risk metrics, a global risk metrics, a link between probabilistic safety assessment and definite depth concepts, application of extended PSA in decision making. And regarding severe accident management strategies, there were top reports on what can be included about nominal power and shutdown reactor states, spent fuel pools, external hazards, etc. So this is really a good database with many variable productions that can be publicly seen on the website, and which really is a reference for PSA. Some of the general lessons learned from this project. First one is that achieving an extended PSA, it was still, but I suppose it is still a pending objective now, as none of the considered power plant sites had a PSA that could cover all reactors' initial states, all possible sources of radioactivity, and all possible types of initiating events, either internal or external, and that could account for a multi-unit accident management. So it's still a pending issue. Another lesson is that there is a need for the definition and evaluation of a global risk matrix. This is a challenge, especially in case of rare extreme natural events, as there are huge uncertainties affecting for instance, the annual frequency evaluation, and especially in the worst cases, when there are combined events or correlated events. In case of external hazards also, the PSA should cover not only the site, the reactor of the plant, but also the wider boundary conditions, the environment, so neighboring source of threats around the site. It can be due to external hazards, of course, but also due to presence of other infrastructures or industries or whatever. And they should also include site features, all the site features, including the case of multi-units, which is not the case for the moment. So it's really recommended to develop firstly simplified approach, but considering a wider environment around the plants and the sites. And regarding specifically multi-units PSA, the conclusion was that there's no special additional work which is needed, as the single unit risk measures can still be applied, and the external hazard screening performed for single units can be used also for multi-units, but there are, however, developments which are needed. Methodological developments, for instance, on inventories and the content of the PSA, because it can be pretty much heavy to account for all the units and the environment. So there's really a need for developments to reduce the cost and to also to introduce site human risk assessment common cause failures, and consider the interface between level 1 and level 2 PSA. Regarding risk aggregation, it's also a difficult task, but it's as difficult as for single unit PSA, I would say. And the applicability of the same quantitative safety targets as for single unit PSA is not clearly established yet, so it's still a pending issue. Now moving to the NARSIS project. So it's a newly launched project, and including 18 partners in Europe, covering also all the sector with research and academic organizations, operators, and technical support organizations. The main objectives were really based on the conclusion, I would say, of ASAMPSA-E, because as there were gaps identified mainly regarding also multi-hazard scenarios, so we focused on the research that could fill the gaps between practice and needs in this domain, and propose improvements of PSA methodologies based also on lessons learned from other projects which are not specifically in the nuclear field. For instance, there's one which was more related to urban systems and multi-aggression to urban systems. So it was a matrix project, and also infra-risk project, which also dealt with critical infrastructures, but not specifically nuclear infrastructures. It was more transports or other types. And of course, ASAMPSA-E. And we focused on 4 main primary hazards and their secondary effects based on what came out from ASAMPSA-E from the end users of PSA in their project. So for hazards, natural hazards, it was interesting to see how we can have earthquake and secondary effects, riverine and coastal flooding, extreme meteorological hazards and tsunamis, and see how we can deal with multi-aggression in this context. So we address a number of challenges in the project. First, there's a part which deals with the better characterization of external hazards, of course focusing on the combination and the cascading effects and related secondary effects. For instance, if we talk of earthquake plus flooding, it can be flood defense damage, which lead to, due to earthquake, which lead to then flooding of a nuclear site, or it can be, of course, tsunami or coastal flooding due to either storms or earthquakes or landsliding, depends. And we want also to better assess the fragility. As I said in the context, we will include functional loss in the assessment. And we are also looking at the cumulative effects that can be, for instance, effects due to multiple loading, external loading, but it can be also effects due to extreme external loading plus what has already been going on inside the plant with respect to fatigue, for instance, or such mechanical effects. We are dealing also with the aging mechanisms, and so either corrosion or the damaging phenomena. And we also want to have fragility models that can account for human factors, because it's one of the main topic also for such analysis. We address also the problem of risk integration and global risk metrics, as it was highlighted by, for instance, ASAMPSA-E. So we propose some possible tool to integrate the risk at the scale of the site and to account for the different certainties that can be existing, of course. And then finally, we have a part which deals with the treatment processing, how we can treat the uncertainty related to expert information, which is one of the pillars of such methodologies, and how we can better constrain this knowledge to be integrated to the other database can be obtained from measurements or simulations. So how we can aggregate all types of informations in a better manner. So it's a threefold methodology with theoretical improvements. We have a verification of the applicability of the effectiveness of what we propose with respect to a generic plant that we will put on different sites in Europe with different types of hazards, existing natural hazards. And the generic plant is more or less generation 2 plant or generation 3. We have both types. And we will perform the whole chain to assess, to see whether our methodology is an improvement to the current practice. And there's also an application which is foreseen at the demonstration level, more for decision-making in case of severe accident management, and which is related to a real operating plant from the project. So expected key achievements is, as I said, an integrated multi-hazard framework to enable probabilistic modeling of the hazard combinations. We propose also fragility models which are derived to be harmonized with respect to multi-hazard considerations and to account for functional consequences and human factors. For the risk integration part, we propose a dynamic Bayesian network modeling which able to integrate the plant complexity, all complexity, meaning technical, social, and organizational aspects, because there are multiple sub-networks in this framework, and each sub-network is dealing with one part of these aspects, and it's able to account for multiple hazard, external or internal scenarios, which can be combined. And as I said, we have a special treatment of the expert judgment constraining. So how we can treat the parameters, the models, and the completeness or incompleteness of information regarding certainties. And we will test the applicability, as I said, on different plants. So for conclusion, there are new horizons for collaborative projects on the PSA in Europe, and that should be defined. So with four main fields of endeavor regarding the improvement of methodologies supporting this type of assessment, such as the NARSIS project, but also the extension of the range of PSA, which is not done yet, in order to include initial operating states, initiating events and internal and external hazards, multi-unit issues, site environment issues, and so forth. And there's a need to share the knowledge between the different actors in the domain, and to improve and harmonize the uses of this extended PSA and in the decision process, decision-making process. Thank you for attention.
Thank you very much. Are there any questions? No, maybe
Hello. So I have a question regarding the initial status of the plant regarding the PSA. Is that part of this project, or is there improvements for a new project to look at the uncertainties regarding the initial status of the plant, maybe some unknown factors, and relating that into your assumptions in the PSA?
Yes, it's part of the NARSIS project because the BN Bayesian network we are developing is dynamic, as I said, but I didn't explain why. It's dynamic because it's accounting for different state or evolution of the plant, possible state, which means that, for instance, you design the framework, and if there's something which is not known at one step of the analysis, you can add nodes or subnetworks, or it's quite demanding, of course, but you could add additional combing information and update all, because we try to do it as non-parametric, I hope, which means that the number of parameters is not fixed in advance, but it's a very demanding task. I'm looking at the guy doing that in the project, and also, yes, it's dynamic, so we can do it, and it has been already applied, for instance, in air transport safety applications with success. So we are quite confident with the fact that it will work here.
Thanks.
Questions?
Thank you. When we did the stress test in Europe, we decided to choose a non-probabilistic methodology, but rather a fully deterministic methodology, and look at edge effect, knee effect, and so on and so forth. Now, what I fail to understand from your presentation is that if I model external hazards before I site a nuclear power plant, then I can understand that this methodology helps me to say I put it here or I put it there, depending on what level of probability I give to external events. And I'm only talking about external events, yeah? But once I have the nuclear power plant which is sited and is operating in a certain point, I mean, what does all this tell me?
So the purpose, I didn't have time to talk of it, but we are combining deterministic with probabilistic analysis. So there's a whole part of the project which will deal with the deterministic approach, direct deterministic approach with a fully detailed analysis, meaning that it's quite demanding for computation, because we want to simulate the whole plant and the whole site. So we are using high performance computing for that. So it's really deterministic. And for the release, for instance, of radioactivity and so forth, we are using both also. So we will compare. The purpose is to have a sort of internal benchmark of that, because it's really useful, I think, for a community to compare things. So we will compare fully deterministic with fully probabilistic, and combination of both methods, and see what it does. So it's the whole purpose of that.
Okay, thank you very much. And one more question over there.
Could you please tell us if the reports of the last project are publicly available or not? Because I saw that you intend to have case study for a specific plant, and I wish to know if there will be publicly available or restricted only for the partners or something.
The generic plant, what we will do on the generic plant will be fully available, because it's a generic plant, so there's no problem. And so it's mainly to demonstrate the methodologies, so there's no problem. The part which will relate to the operating plant will not be available, I'm afraid, because it will be only for Europe.
I have a short question. So first one is easy, actually. It's related to the progress on safety goals for multi-unit stations. So what's the current status? Will safety goals be revised to include situations when you have site with, for instance, 4 or 8 reactors? And then the second question I'll come back to later.
So in our, at least in the project, NARSIS project, which I know better, we do not intend to have multi-units. We will have only 1 unit, but the whole plant, however. Okay, so it means that you can have auxiliary buildings and so forth, or pools or whatever. So for I hope that we will come up with recommendations, of course, regarding at least single units, PSA, but in the context of multi-hazards and combinations, because that's what is really new, I suppose.
And that was my second question, because I know that methodologies for fire PSA, for example, are very different from methodologies for something like flooding PSA or seismic or tornado. So how do you combine these different methodologies for producing one PSA?
So the whole point is to see how we can harmonize the data. I mean, for instance, if I talk about the fragility assessment, usually we have, of course, different types of inputs and outputs, and we want to see if we can have the same risk metrics to be inclusive of all this in a harmonized way. That's what that has already been done for other critical infrastructures, as I mentioned in the infra-risk project, which is, I suppose, their outputs are public. And so we want to apply it, for instance, considering what we call multi-functional fragility models, not just one curve, for instance, but we will take many input parameters to produce sort of a surface fragility, in which we can have different ways of looking at it, and so depending on what we are looking for, there will be many inputs, which can be inputs coming from different hazards or different damaging intensity measures from one hazard, so it depends, but it's a way to account for many different types of aggression.
Okay, thank you very much, Ms. Foster. Sorry, I overlooked one.
Okay, this
We
is
have
just
time,
a
so
generic
you may-
question. These projects are focusing activities in have a generic interest beyond competitiveness. My question is how much you interact with other international organizations, activities beyond Europe, and how much you impact their conclusions, you influence their conclusions.
For the moment, we interact within Europe, with other organizations within Europe, but not outside, unfortunately. For the moment, we are not. But yes, we intend to do it at one moment, of course. Because we have a small interaction, however, it's not completely true, because, for instance, we have the first workshop of NARSIS, which is will be in September, next September, and we will have an interaction and roundtable with a US person, which is also having same kind of research and methodologies about multi-aggression and combination. And so we'll have his point of view. He will make a keynote there, and we will have a roundtable to see how we can deal with perspective, at least between Europe and the United States.
Also to Taki's question, I must remind that the NARSIS project is presented at every Nuclear Forum or at Technical Area 1 meetings, so this is also some dissemination of interim results.
as a European project, interact with other international organizations' activities, which has a project focusing exactly on the same issue. And it's very important to speak in one European world to their activities, where a number of organizations, individual, are there. Okay, that was the point.
So we try to make it.
Okay, I don't see any hand anymore. So thank you very much.